Now, here's another way to just solve for displacement when we don't know the final velocity, okay? So in this case, we don't know the ending speed that we're at. We do know our acceleration, we do know our time and other variables. To do that, we take our previous equation and the one from 2 slides ago, combine them together, do some substitution, and voila, we get this guy. Now, it looks way more complex because it is. Let's work through it though. We're going to say our displacement is equal to the initial velocity times the change in time plus half of our acceleration times our time squared. Okay? Hopefully, ideally, we would start from rest or start that we have no velocity to start, because if that's the case, our initial velocity here would be a 0 and we can get rid of this whole part of the equation. Okay? So it's one of our favorite things if we start from rest or start at 0 in this scenario. All right, so here's our problem that we're going to work on. We have, again, a scenario where we are dealing with, let me copy this over here quick. Drag it down a little bit. So we're dealing with the variables that we know, and let's work it out. So we throw an apple downwards at negative 2 meters per second. Okay, so initial velocity is not 0. We're going to have to deal with that first part. Okay, so our initial velocity is a negative 2.0 meters per second. Negative, important. Off the Mendota Bridge. The acceleration due to gravity is a negative 9.81 meters per second squared. It takes 2.4 seconds to hit the water below. 2.40 seconds. Time is always positive. Okay? We do not know the final velocity. No clue what this is. In fact, we don't care that we don't know that. We want to know how high up we are. So we want to know our displacement. So this is what we're going to solve for right here. Okay? So let's set our equation up. We know that our delta x is going to equal our velocity initial times our change in time plus half of the acceleration times our change in time squared. Okay? Squared. Plug it in. Velocity initial was a negative 2.00 times our time, which is 2.40. That whole area is going to be added to half our acceleration, which is a negative 9.81, times our time, which is 2.40 squared. Running out of screen here a little bit. Okay. If we plug all this into our calculator, do not forget the squared function here. That's pretty common. Don't forget your negative signs. That's pretty common. People end up having problems with that. If we plug that all in and we solve for this, we end up with an answer of a negative 33.1 meters. Okay? That's our delta x. It's not our final answer. Our final answer is, well, we want to know for how high up are we, right? Well, it fell down this far, right? It's a negative, so it fell down 33.1 meters per second. So our height above the water would be a positive 33.1 meters high. Okay, so this would be our final answer in a problem like that. All right. Little trick to the end there. This is how far it fell. The question asked, how high up are you? So we change our sign or identify that's that high. Okay? That's our third one.